Measure of spread. Hendricks? Okay, so how we talked about to measure spread. And so let's connect that with what a normal distribution really looks like. So here's a picture of what a normal curve looks like. We already talked about it, so you should already have that down. But this is what the main thing is here, what we're going to talk about. This is a normal distribution. Notice it does look like a bell curve. Now, what I want you to gather from this is two different things. Notice how you have the middle, which is right here. That's where your mean is at. That is the mean. And notice how there's breaks in here, right? There's one break, 2, 3. And of course there's more, but we've got 1, 2, 3, and then in the other direction we also have 1, 2, 3. Those are the main breaks that you want to know about. Those are the important ones, okay? Each one of those distances here, from here to here, is called a deviation. Okay, the name of that actually is a standard deviation. So make sure that you know that, a standard deviation. So when we talk about standard deviation, that's what you want to visualize. How far away from the norm am I? If you are one standard deviation away, then you would be at 115 if the mean was 100. Okay, so in this case, 2 deviations away would put you at 113. Does that make sense? Can someone tell me what the value of the standard deviation here is? How much? What is the length of one standard deviation? Just by looking at the chart.
15.
Yeah, it's 15. Okay, so the standard deviation in this case is 15. Okay, and of course you can calculate that. You guys aren't supposed to know how to calculate that, but yeah, it's kind of weird. We'll talk about that another time. What I really want you guys to learn here is you need to understand that one deviation in both directions. Do you guys see this blue region? That makes up 68% of the data. Do you see that in here? That is 68% of the data. If you move out 2 deviations, now you're at 95% of the data. So 2 deviations out, that means from here all the way to here, that is 95% of the data. And then one more, so the 3 marks, that's going to be 99.7% of the data. So this is called, believe it or not, there's 2 names for it. This is called the 68, 95, 99.7 rule. Got really fancy with that name. Okay, that's how the distribution behaves. Another name for it is the empirical rule. Personally, I like that one because that forces me to repeat those three numbers over and over and over and over. Okay? Make sense? So do you guys have those 3 numbers down? Something else that you need to know about the normal distribution is that the area under the whole curve, is 1. Always 1. No matter what, it's 1. That doesn't make sense, huh? Okay? Well, it should make sense. Okay? Because 1's a whole number, right? How do I convert a number into a percentage? You move it over how many spaces? 2. So if I move it over, now it's a percent. Should it 100% of the data be under the curve? Okay, so mind blown. So, oh, that looked like a face. It looked like a little cat. Let me do it again. Yay! Sorry. All right, anyways. So, important things you need to know. Area under the curve is always going to be 1. 1 deviation out from the norm is going to be 68% of the data. 2 deviations out is going to give you 95, and 3 out is going to give you 99.7. Anything further than that, we don't really need to know because the percentages are so small, and to be out there, it's really going to be a very unique situation. That's where you're going to have like your naturally born geniuses or whatever. Okay, and this distribution should make sense to you guys. Okay, because have you guys ever seen this in play?
No.
Sure you have. And I think you've seen it at school a lot. Yeah. If you're in here, you're a C, B, A, D, F. That's why you have a lot of C's, a lot of average scores. Okay, that's what they use.
Is that why they say C is the average, like just average?
Exactly.
It's not bad. It's not
Okay, that's where you're supposed to be. Okay, so guys, to get a C is not bad. I like being average. People that are not average get noticed. Didn't you just say that? Don't you want to be a bench warmer?
Yeah.
Same thing.
Sometimes, well, I mean, when you're at the top, like you've already, why do you want to be in the limelight? You're at the top. Like if I made it to the NFL, I'd be cool with being a bench warmer. Like college, high school, everything, I'd want to be a starter until I made it to the top.
But you're not at the top if you're a bench warmer.
You're still in the NFL.
You're gonna tell me that? I'm in the NFL. You're gonna tell me that? I'm in the NFL.
I'm not, but I'm just saying that's
Exactly.
technically that's not the top though.
Well, I don't know that.
I'm satisfied.
Because I'm out there. I'm out there making NFL money. I don't know that.
I'm close. I'm satisfied with being close to the top.
Yeah, I can see the top. I'm
Okay,
with
I
it.
wanted to do something. I just blanked. I had a totally different presentation ready, and I don't think we hit that enough. So you guys aren't ready for that. The next one's not really that tough. So, but I want to make sure I get this practicing with the normal distribution and stuff. Okay. So, let me ask you this question. If I said, if I could spell, that would be nice. So if I said that you were, let's see here, 2 deviations above, that doesn't look like above, does it? Quit hating on my writing. If I said you were 2 deviations above the average, if I said you were 2 deviations above the average, what percent of people are you better than?
I don't want to say it out loud.
No, we want you to say it loud.
Is it 100?
It's not a secret.
Is it 125%? 15 plus 50, that's 30.
Okay, hold on.
Plus 95.
Hold on, slow down. What is the area under the curve?
1.
1. That represents?
Oh,
100%.
100.
Can it ever be more than 100?
No.
Oh, I was thinking about the standard.
Okay. 2 different questions here going on, right? So you have to think about this differently. So if I said, hey, you know what? You scored 2 deviations above the norm, then what percentage of the people are you better than?
3. Or, I don't know, man.
Okay, I just gave you some percents to play with.
Yeah, that's what I'm thinking too. Like, hold up. Hey, can we go back to
Red,
that?
what do you got?
That little like.
Is it in your notes?
It's not.
Oh. Why is it not?
I mean, I don't have my notebook today, so I'm kind of savoring the notes. Thank you.
So if I said you were 2 standard deviations above the average, what percentage of the people are you better than? What do you got?
31.7.
Nice try. Thank you for playing.
Is it 48?
48?
Close.
Nice try. Thank you.
25.
Let's see here. 1, 2, 3, go. Nah, nice try. Thank you.
99.7.
Nice try. Thank you.
99.7?
68.
Oh shit. You're not.
Nice try. Thank you. That was good though. But guys, the numbers are there. Think about that. If I told you that you were 2 deviations above the average, what percentage of the people would you be better than?
Everybody.
51.
Everyone.
1.
100%.
85.
I mean, I'm better than 100% of the people.
Okay, before you hurt yourselves, or give me every possible combination. You guys ready for this?
50.1.
Okay, say that one more time.
50.1.
Ah, thank you for that. No cigar. Okay, where is 2 deviations above, guys? in this case. Now these numbers don't matter. They're from something else. But 2 deviations is definitely here, isn't it? Okay, so here's 2 deviations. I think I meant to say 1 deviation, but 2 deviations. So if somebody said the correct answer, then I'll make myself. What percentage of the data is from this point down, people?
50%.
Yeah, it's 50, isn't it? So 50 from here down, what do I need to add to that 50? 34 and 14, don't I? Okay,
So it'd be 90%.
so it would be how much?
90%.
No,
Wait,
it can't be 100.
98.
98%.
34 plus 14 is 50.
48.
No, it's 48%, 98.
Oh, okay.
Okay, okay,
Yeah,
good.
never
So
mind.
98% of the data, right?
Yeah.
Good. If I told you that you were 1 deviation below the norm, then what percentage of the people are you better than? If I told you that you were 1 deviation below the average, then you'd be better than what percent of the people?
16.
How much?
16.
16? How'd you come up with that?
2 plus 14. 1 less than average, so you're less than the 34.
What about this 0.1 though?
So you have to say 14.
Okay, you're right, but here's a better way of doing it. I know that from this point all the way down is how much? What percentage of the data is that? 50%, right? And if this is 34, then just subtract them, and you're going to get your 16. Okay. Now these are rounded off, and that's why you're able to get that 16. But technically, this thing keeps growing, actually getting smaller, but it goes on forever. It's this thing called asymptotic. That means it gets closer, but it never crosses it. Okay. Now, here's a question for you. I'm going to get rid of this now because it's got all the numbers on here. Everybody got your numbers? It's going away. What percentage of the data is between -1 deviation and 2 deviations? So I want to know in here. Can you figure that out? What percentage of the data is between a -1 standard deviation and 2 deviations? 30?
Yep.
Nice try. Nice try. Red?
82.
82? How'd you come up with 82?
Because the first deviation was just -1,
Uh-huh.
and then the second deviation is
Yeah.
going to be 68%, and then you just add 14 because it's
You guys catch that? Between -1 and +1 deviation is 68% of the data. This is 14% of the data, so you just add the 2. Therefore, it's 82% of the data is in there. Okay. Can you tell me what percent of the data is above 2 standard deviations?
2.1 with the bar over it.
2.1?
With the bar over it.
2.1111111?
Yeah.
Anybody else got something different? You don't have the numbers down? Do you have the numbers down?
46%?
From above 2 deviations?
Oh, wait, no.
We kind of did the opposite of this, didn't we? A minute ago? 2 minutes ago? 5 minutes ago? Martel's the one, or was it you, Chancey?
Yeah.
If you take a look at the distribution, Didn't we say this was 50?
Yeah.
And then we said 98? So 2 deviations above that would give you simply the 2%.
So,
Right, because the whole curve under there is
1.
100, correct. Alright, cool. Well, that's
Wait,
all
so
I
I was
wanted.
right?
No.
Oh.
Nice try though.
Was I right?
You were right.
Alright.
It's 2 point. It's 2%. Technically it's 2%. Okay. Questions on how standard deviation works? Cool beans. How are we on time? Maybe I have time to start. It's 1. Okay. This won't take very long, so hallelujah. I wanted to do. Let's see here. 13, 14, 15. Any 16-year-olds in here?
I'll be 16 like
17-year-olds?
I'm 16.
Okay, that's 17. All right, cool. So, boy, girl, girls. Okay, so I've got two categories. Actually, I have how many categories here? 8. You mean 6?
4.
I got 6 different categories, right? You can be a boy or girl. You can be 13, 14, 15, 16. Okay?
Oh, okay. I see.
Okay. So, how many boys do we have total? Actually, raise your hand if you're a boy and you're 13. If you're a boy and you're 13. 0? If you're a boy and you're 14. 1, 2, 3, 4, 5. If you're a boy and you're 15. 8. And if you're a boy and you're 16. 1. Thank you. If you're a girl and you're 13.
Oh, I thought you said.
All right, cool. 0. If you're a girl and you're 14. Awesome. If you're a girl and you're 15.
Wait, what? Wait, did I raise my hand on accident?
No.
Oh, okay.
1, 2, 3, 4, 5, 6, 7, 8. And if you're a girl and you're 16. 2. Awesome. All right, cool. Now, notice how there was 2 conditions every time, right? So technically we had 8, and I think that's what someone was trying to allude to. We have 8 joint distributions here. We have whether you're a boy and you're 13, you have boy and 14, and so forth, so forth. So these are all the joint probabilities here, okay? Now, of course, you guys know how to. You guys have seen two-way tables, right?
Yeah.
Okay. So we know that at the very bottom, what do we do with that? We add this column called, or sorry, this row called totals. So we can figure out exactly how many boys we have in this class. So we've got 15. No, just kidding. 14. Yeah.
No, we actually do.
So it's 14, and then how many girls do we have? 11. But we can also figure out how many 13-year-olds we have, how many 14-year-olds, how many 15-year-olds, and how many 16-year-olds. Now here's the deal here. In this space, we should have the grand total. The numbers that are adding up across this way should also add up and down. So if we have, 25 people, then these three numbers should add up to 25 as well, and do they?
Yep.
Sweet. So we have a grand total of 25. Okay?
What if there's an outlier? Like, does an outlier count on these?
I mean, yeah, it's actual count data, so it's not going to be a big diff in here, okay? Now, here's what you need to know. These are the joint distributions. In here, those little ones. If you take a look at the totals that we added at the end, this is the marginal distributions. Notice how they kind of go at the very end, kind of like where the margins would be. So you need to know that these are called the marginal distribution. So this would be the marginal distribution for the columns. This would be the marginal distribution for the columns, and that would be the marginal distribution for the rows. Okay? So they're just called marginal distributions, and then the others are the joint distributions. Simple enough? Now what's really cool about these is once you start getting to probabilities, then these really help you out. Okay, because if I said, hey, you know what? If I wanted to pick someone in this room at random, what's the probability that that person would be a girl and 16? Then I can just go down to saying, oh, girls and 16, well, there's only 2 out of how many?
25.
And that's your probability. That's easy, huh? Okay, cool. So let's take a look at this problem here. I like these because they almost feel like puzzles, almost like Sudoku kind of thing, okay? Because you know what's supposed to happen, right? And all you have to really do is start filling in the rest of these. So could we figure out how many freshman skateboarders we're supposed to have? How many? 32. It's 32 because we have 60 total, so 28 and that number need to add up to 60. Okay? Now, I can also figure out how many senior snowmobile people I've got, which is 30. I want to double check, make sure they add up to 58, and they do. 60 and 40 should make 100. And this should be 42. There you go. Hallelujah. Okay, very easy two-way tables, yeah? Huh? No. Okay. Now, what we're going to... Oh, I want this one over here with the other one. Now, what I'm going to do with this one is I'm going to create this thing called the relative frequencies. Okay, have you guys ever heard of relative frequencies? Relative frequencies are not that difficult. This is still 100%. So, I'm going to put 1 here. Now, I want these to be as a decimal. And what I'm simply going to do is turn these into pretty much decimals by taking that specific value and dividing by the total. So what's 42 divided by 100? 0.42. This will become a 0.58. Senior skateboards. What's my relative there? 10 divided by 100? 0.1. How about the 30? What's that become? 0.3. 0.4. 0.28. 0.32. Okay, so at the top I've got my distribution. Down at the bottom, this is called my relative frequency. Oh man, you get it. Relative frequencies, okay? Questions between those two? So the homework today is simply going to be on these two-way tables. Not a big deal. You don't need to sweat on it. Okay? Questions on two-way tables? Super easy stuff, huh? Cool. Right on.
Oh yeah, what about the